Welcome to What is Engineering? This video is a part of a series in Foundations of Engineering by Conceptual Calculus. The words engineer and engineering have different meanings in different contexts. A railroad engineer drives a train. Social engineering is used to gain illegal access to computer systems. These two very different meanings both come from the Latin root ingenere, which means to create. The same Latin root gives us the words ingenious and ingenuity. Engineers use their ingenuity to create ingenious things, including locomotives and ways to get people to allow access to their systems. From that broad concept of creating come many different fields of engineering. In 1947, the American Engineers Council for Professional Development defined engineering as the creative application of scientific principles to design or develop structures, machines, apparatus, or manufacturing processes, or works utilizing them singly or in combination, or to construct or operate the same with full cognizance of their design, or to forecast their behavior under specific operating conditions, all as respects an intended function, economics of operation, and safety to life and property. The world has changed since 1947, but engineering is still about creating, designing, developing, constructing, and operating, and it still prioritizes safety and economics. This course is part of a program designed to lead to a bachelor's or higher degree in engineering from a U.S. university. This video is about the kinds of engineering that the university programs prepare you to do. We don't drive trains. This video focuses on these 13 fields of engineering: aerospace and ocean engineering, biological systems engineering, biomedical engineering, chemical engineering, civil and environmental engineering, computer science, construction engineering and management, electrical and computer engineering, industrial engineering, materials science and engineering, mechanical engineering, mining and minerals engineering, and systems engineering. The initials of Virginia Public Universities with programs in these areas in 2024 are at the bottoms of the slides. Aerospace and ocean engineering. Aeronautical engineers design vehicles and devices that fly through the Earth's atmosphere. Astronautical engineers design vehicles and devices that go beyond the atmosphere into space. Together, they form aerospace engineering. The connection to ocean engineering becomes clear when you realize that air is a fluid, so a plane moving through air and a submarine moving through water involve similar principles. Biological systems engineering. The Virginia Tech website says, by integrating biology and engineering, we address complex critical needs in sustainability, environmental protection, and human health. Our graduates develop engineering solutions that safeguard land and water resources, detect and prevent human diseases, and produce food, pharmaceuticals, and polymers. Biomedical engineering. Biomedical engineers use engineering principles to improve human health. Biomedical engineers design insulin pumps, dialysis machines, artificial organs, and prosthetic limbs. They also design diagnostic equipment such as MRI, CT, and ultrasound scanners and robotic arms used in surgery. Chemical engineering. According to the University of Virginia website, chemical engineers are involved in developing, processing, and marketing such varied products as fuels, pharmaceuticals, foods, plastics, metals, microelectronics, and basic chemicals. Civil and environmental engineering. Civil engineers design infrastructure such as roads, bridges, airports, dams, water purification and supply systems, and wastewater treatment plants. Motivated by the environmental impact of these projects, civil engineers led in creating the emerging field of environmental engineering. Computer science. According to Virginia Commonwealth University, computer science specialties include machine learning, artificial intelligence, data science, cybersecurity, robotics, bioinformatics, natural language processing, virtual reality, software engineering, data mining, high performance, and cloud computing. Construction engineering and management. Construction engineers work with architects and project managers to design and manage construction projects. Electrical and computer engineering. According to the University of Virginia website, electrical engineers analyze, design, and implement creative solutions to problems with electrical and electronic devices and systems. These devices and systems may be as small as a computer chip or as large as a power generating plant. At Virginia Commonwealth University, electrical and computer engineering specialties include autonomous vehicles, robotics hardware, medical devices, cyber-physical systems, drones, wearable devices, smart technologies, controls, electronic design, and nanoelectronics. Industrial engineering. Industrial engineers design and improve industrial equipment, systems, and processes to increase safety, quality, and efficiency. They work on assembly lines, facility layouts, workflow processes, supply chains, and transportation systems. Materials science and engineering. The terms Stone Age, Bronze Age, and Iron Age have been used to describe eras in human prehistory. This reflects the great influence that our materials have on what we can make and do. When new materials are developed, such as bronze and iron, they open new opportunities for technological progress. Materials scientists and engineers continue this advance, researching the properties of materials and developing new materials to meet modern needs. Mechanical engineering. According to the U.S. Bureau of Labor Statistics, mechanical engineers design, develop, build, and test mechanical and thermal sensors and devices. Anything with moving parts is mechanical, making mechanical engineering one of the broadest engineering disciplines. It is also among the oldest. Mining and minerals engineering. According to the Geological Society of America website, a mining engineer is a professional who is responsible for the design and development of mines, as well as the extraction and processing of valuable minerals and resources. They use a combination of engineering principles and geology to determine the best methods for extracting resources, while also taking into consideration the environmental impact, safety, and cost. Systems engineering. Systems engineers look at the big picture. It is not enough for each individual component to function. The components must work together. According to the International Council on Systems Engineering, systems engineering is a transdisciplinary and integrative approach to enable the successful realization, use, and retirement of engineered systems using systems principles and concepts and scientific, technological, and management methods. This video shows only the tip of the engineering iceberg. There is more to each of these 13 fields than was described here, and there are other fields of engineering in addition to these. I hope this video helps you start to find your own engineering career path. Conceptual Calculus thanks VIVA, Virginia's Academic Library Consortium, and New River Community College for their generous support.